Alright, hi, welcome to Calculus. We're talking about basic differentiation. And differentiation definitely deals with the tangent line problem in which we approach the limit of the equation that gives us the slope for any function at any given point. Okay, so first off, we're going to take a look at this website from Brown University. It has some pretty good basic differentiation rules. So let's go ahead and start talking about it. Alright, so the derivative of a constant is 0. Okay, so if we take a look at the difference quotient here, okay, which is the limit as h approaches 0 of f of x plus h minus f of x. Okay, if we plug those things in, the constant minus the constant is what we're going to be doing, and that's going to be 0 over h, which just becomes 0. Okay, alright, so the definition is the derivative, and basically what we're getting at here is we're trying to get away from the difference quotient, and we're trying to get to some simple rules to just remember to do some derivatives, and this is just one of them, and I just did a proof. Okay, so find the derivative of the function f of x equals natural log of 3 plus root 5. It looks pretty complicated, but since it is a constant, pi is a number. Natural log of 3 plus root 5 is a number as long as it's positive. This is just one number, so it is 0. So the derivative is 0. Okay, now the constant multiply rule. Alright, the derivative of a constant multiplied by a function is a constant multiplied by the derivative. Makes pretty much sense. So what you're going to see is a lot of the times I'm going to take this constant, move it out front, and then do the derivative of the function. Okay. Alright, now this is easily provable by using the definition of the derivative or the difference quotient. Okay, and if we just plug everything in. Alright, as you can see, I'm going to have a in there a couple of times. And if I factor it out to the front, it's just going to be a times the derivative. Okay, so for example, d dx of 3 times x squared plus 1. Okay, it's going to be 3 times the derivative of x squared plus 1, and then just work it down to 6x. And you'll learn how we get 6x in a little bit, okay? Alright, multiply rule. Alright, the derivative of a function a of x is given by a times that actual function. This is actually the product rule. We won't go into that too much right now. Sum and difference rule. Okay, the derivative of the sum of two functions is the sum of the derivatives. So that one's pretty simple. So if you're adding two functions, it's just basically like, and you're doing the derivative of that sum, it's just the same as if you did the derivative of the first function plus the derivative of the second. Okay, so for like example, x squared plus 3x minus 2 tangent x, okay, it's just going to be the derivative of each part. And so that turns into 2x plus 3 minus 2 secant squared x. Okay, alright, product rule, pretty much going to be a new thing for you guys right there, and a lot of this stuff right down here is going to be some extra stuff. So I want to go over the actual measurements, okay, the actual rules. There's some rules that we're missing a little bit, and I'm going to add those to it. Okay, so derivatives are basically just the shortcut for the quotient rule. So when you're looking at that, just understand that, and you should be good. So let me bring up that other one. Okay, there we go. Here's what I'm looking for. Okay, so this is mathisfun.com. Okay, so there's the constant. Alright, now here we go. If we're doing a constant which is x, the derivative is going to be 1. Okay, the derivative of a square is going to be 2x. The derivative of square root, which is x to the, which is basically the same as x to the 1/2, it's going to be 1/2 times x to the negative 1/2. Okay, exponential, the derivative of e to the x is e to the x. The derivative of a number to the x power is that number to the x power times the natural log of a. Logarithms, the derivative of natural log is going to be 1 over x. And you'll understand why we don't do x to the negative 1 up here. Okay. All right. The log base a of x is 1 times x times the natural log of a. Okay, and then in trig, sine of x, the derivative is cosine of x. The derivative of cosine of x is negative sine of x. The tangent of x is secant squared x. The derivative of sine inverse of x is 1 divided by the square root of 1 minus x squared, and the derivative of tangent inverse of x is 1 over 1 plus x squared. Okay. All right, and here's the rules. Now, multiplying by constant, you just multiply the constant by the derivative. Pretty simple. All right, now the power rule, okay, is x to any power is going to be, the derivative is that power brought down to the front as n times x to the n minus 1. So you're going to go 1 power less. So if this was x to the third, this would become 3x to the second. Okay. Sum rule is just basically you add the two derivatives together. Difference rule is you subtract the two derivatives together. Product rule we'll cover in future lessons. Okay. So some examples. What is the derivative of sine of x? Well, if we go back up to our rules, the derivative of sine of x is cosine of x. So we just write it as cosine of x. Now you can write it as d dx of sine x is going to be cosine of x, or the derivative of sine of x, I like to write it as f prime of x, and this is usually called prime, equals cosine of x. Okay. All right. What is d dx of x cubed? Just like I said up there, we're going to use the power rule. Okay. So it becomes x to the n equals n times x to the n minus 1. So it's x to the third, which is 3 times 3 x to the 3 minus 1, which is 3x squared. Okay. What is the derivative of 1 over x? Well, this becomes x to the negative 1. Always try to rewrite it as in terms of exponent, because the power rule's so easy. Just try to do it that way. Okay. We can use the power rule where n equals negative 1. So we just bring it down in front. So the derivative of 1 over x becomes negative x squared. Okay. What is the derivative of 5x cubed? It should be the derivative of any function with a constant and you're multiplying is you just multiply the constant by the derivative. So this becomes 15x squared. Okay. Now the sum rule. What is the derivative of x squared plus 3x cubed? Okay, so you're going to do the power rule here and get 2x. You're going to do the power rule here and get 3x squared. And so it becomes 2x plus 3x squared. Difference rule, same thing, except it's with subtraction. So if we use the power rule here, we should get 3v squared minus 4v cubed. Ta-da! That's what we get. Alright, sum, difference, constant, and multiplication and power rules. If we combine them all here, this is going to become 10x or 10z plus 3z squared minus 28z to the third, which is right down here. Okay? Alright, we're not going to get too much into the product rule right now, but that's the basic rules for differentiation. Thank you very much and have a great day.